In the single bullet theory, it passes through multiple materials. Kennedy's neck, then air, then Connally. So the next step is to recreate what happens when a Carcano bullet hits human tissue.
It's basically a splash. We're basically a bag of water. If you throw a rock into the water parts. So does muscle tissue to high-velocity bullets.
To learn how muscle tissue parts when penetrated by a Carcano bullet, they'll use two different tissue simulants, ballistic gelatin and ballistic soap. Both have the same density and resistance to penetration as human muscle. But they behave differently when struck by a bullet.
We're looking at a temporary cavity in gelatin that opens up and collapses.
But ballistic soap freezes the moment in time, preserving the wound cavity.
That temporary cavity is formed by the splash, by the plow of the bullet through it, but it stays there.
The pine boards have already shown that a Carcano bullet can easily go straight through two people. But the single bullet theory is all about what it does after it emerges from Kennedy's neck. Does it remain intact? Is it deflected? What happens to its velocity?
How fast was it going? That's important to know. What kind of damage can we expect it to do to another gunshot victim, such as Connally, or to the car?
In these 3 feet, the space between Kennedy and Connally, lie the answers that prove or disprove the single bullet theory. They'll start with the soap.
It's very similar to Neutrogena, that clear amber soap that you can see through. This has the same density and the same resistivity to penetration as muscle tissue. I've also put this cloth on here so we can see a phenomenon called bullet wipe.
Range is hot.
5, 4, 3, 2, 1.
Gonna say.
First thing to notice is this cloth with the bullet hole in it. The dark ring you see around there is a phenomenon known to forensic scientists as bullet wipe. It's the smudgy material on the surface of a bullet that literally wipes off as it pushes through the first surface it encounters. This is important because it tells you direction. This is an entry. There is bullet wipe around the small round hole in Kennedy's coat. Okay, I've removed the cloth and the skin simulant. Here we have something different. We have a representative of the temporary cavity that the tissue would have been hurled out, propelled out, but in a real person or in tissue or gelatin, it had collapsed back. This is the exit, and we can see it's very little different in size than the entry. Okay, I've sectioned this lengthwise along the wound track, and the noticeable things are that it's perfectly straight.
But near the exit, the wound path gets wider. Something's happening to the bullet.
This is the entrance. The bullet stays stable, 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 nose forward. Over here's the exit, and it's just starting to yaw.
Yaw means the bullet is changing its orientation in flight. It's still moving in a straight line, but it's starting to tumble. High-speed video shows the bullet beginning to yaw after it emerges from the soap. Now they try a shot through gelatin.
Okay, on target.
5, 4, 3, 2, 1.
The wound path opens up, then collapses. And just like firing through soap, the bullet goes into yaw.
Oh, another yawing, tumbling bullet. It's almost in perfect yaw, maybe at 80 instead of 90.
Beyond the target is a witness panel, a piece of 1/4-inch sheetrock. It's 3 feet beyond the soap, the same position Connally was in 3 feet beyond Kennedy. The witness panel records the bullet's orientation after exiting Kennedy's neck.
We've got an intact bullet. It's not deformed. We can see the profile of it. There's the nose, there's the heel or the base, but it's going sideways. Here's an actual fired Carcano bullet, and we can see it's almost perfectly in profile. Connally's coat has this kind of a hole in it.
And so does Connally's back, according to his surgeon. In test after test, the Carcano bullet moves straight through tissue simulant, but tumbles when it re-enters the air.
time after time, the instant this bullet is back out into the atmosphere, it goes into yaw. That was a real surprise. I can't explain it, but from a science standpoint, it's repeatable.
A bullet hitting sideways has much more resistance, which helps explain Connolly's wounds.
It's like holding your hand out the window of a car going 90 miles an hour, so you feel a lot of resistance. If you put your hand like that, you feel very little. So when the bullet hits Connolly, it's now going sideways, and it does a lot of damage.
The sideways bullet has a bigger profile and is slowing down. That makes it easy for it to break bones without much damage to itself. And in fact, the stretcher bullet is damaged.
If you look at it end on, it's mashed very considerably. It's actually in an oval shape, not round. So it has suffered some damage.
And it's exactly the type of damage a bullet would get from hitting sideways. Operating on Connolly's wrist, doctors found bits of lead. Luke Haig thinks the soft lead was squeezed out of the bullet's hard copper jacket like toothpaste from a tube, because it was going sideways.